Welcome, MA 103 students. This video AI corresponds to the lesson entitled Introduction to Discrete Dynamical Systems. In this video, we will focus specifically on the last lesson objective listed here, which is create a mathematical model of a recursive relationship using the transform step. The transform step refers to the useful mathematical modeling process. And in this process, we take a real-world scenario, transform it into a mathematical model, which we can then use appropriate techniques to solve. When we transform, it's helpful to include three elements. The first, we need to define our variables, and these will represent the quantities of interest in our problem. Two, we need to identify all assumptions, and these assumptions must be reasonable and necessary. And three, we need to develop a model. And in this case, our model will be a discrete dynamical system. And a DDS consists of the initial condition and a recursion equation. The next section has a nice problem that we will use to discuss this lesson objective. Create a mathematical model of a recursive relationship using the transform step. In a later video AI, we'll go on to solve this problem. In this problem, a cookie jar savings account does not earn interest because all deposits are placed in the cookie jar on the kitchen counter. If you start a cookie jar account with $15 and then add 75 cents every day as you come home from work, the question is, how much money will be in the jar after 1 year or after 2 years? And again, we're going to focus specifically on transforming this problem. We want to include the three essential elements, but first, let's identify what's given. We know that we start this account with $15. Additionally, we know that we add 75 cents every day, only when we come home from work. We know what we need to find. We need to find the amount of money that we actually have after 1 year or after 2 years. And to do this, we need to define a variable that represents this quantity of interest. So let's define a variable. Let's define P sub n, where P sub n equals the amount of money in dollars in the cookie jar after n workdays. And we specify that index n as days, and specifically work days. Let's see if we can identify some assumptions for this problem. Since I'm focused on money in my account that's being deposited every workday, I want to assume that I consistently deposit in that cookie jar every single workday. But I need to also make an assumption on the days that I work and how many days I work in a year. First, I'm going to make an assumption that I work 5 days a week. If I work only 5 days a week, I need to also make an assumption on how many weeks of the year that I actually work. I'm going to assume that I get 2 weeks of vacation a year, and therefore I work 50 weeks out of the year. Based on these two assumptions, I can make an assumption on the number of days that I actually work in 1 year. 50 times 5 gives me 250 days in 1 work year in which I deposit money into my cookie jar account on my kitchen counter. This assumption is both necessary and reasonable. This assumption is necessary because I want to find how many workdays I actually deposit money into my account so I can answer this question. This assumption is also reasonable. It's reasonable that I only have change to actually put in this cookie jar account after I come home from work. It's also reasonable that Americans typically work a 5-day work week, and that there should be some allotment for vacation. Now we need to create a model. And I want to use a discrete dynamical system. But why? This problem is definitely discrete. The domain n is in days. It's not a continuous function. We're depositing at discrete intervals, and in this case, we're depositing every single workday, and therefore a DDS would be appropriate. To determine my initial condition, I know that I start my account with $15, and therefore P sub 0, P naught, equals 15. Next, for my recursion equation, I want to know how much money is in my account given some work day, some index n. And therefore I want an equation, P sub n, and I know that how much money that is in my account today, right now, equals all the money that was in my account the day before, plus or minus any change that occurs to my system. So I can start this recursion equation with P sub n being equal to P sub n minus 1. But now I need to add or subtract the things that change every single day. And in this case, we only have one thing that changes, and that is the addition of 75 cents every day to my account. So in this case, I have a recursion equation where P sub n, the amount of money in my cookie jar after n work days, is equal to P sub n minus 1 plus 75. And this is my model that I can then use to solve. Stay tuned for the next video in which we solve this cookie jar problem. Thanks for listening.